automation of your deployments, that's pretty much a given. If you have a visible delivery pipeline, in other words, you know what was released, you know if a particular build has been released yet, or if it was never released, you know where things ended up, or you have a way of finding that out very easily. You run automated tests in all your environments, including production, and you're in a position where you could release your code with quality at any time, even if you don't. And this is kind of an important point. That you'll sometimes hear the term continuous deployment used. And continuous deployment and continuous delivery are almost the same thing, the way I look at it. Continuous delivery means that you're doing all of these things, but you may still have business reasons that you don't release anytime you want. There may be obstacles that prevent you from doing that. Continuous deployment means that you're literally, as soon as that build has gone through all of your checks, it goes straight out to production. So that's an important distinction. And what are some of the drivers in the industry towards continuous delivery? Well, one of the biggest ones is the fact that a number of companies have figured out how to do this. In the last 5 years, you see a number of companies that are doing releases multiple times per day. Google, Facebook, Amazon, Netflix are among some of the ones that will get mentioned quite frequently. Even Microsoft does that now. By the way, does anyone here have Windows 10, either at home or on your work computer? You've probably discovered the wonderful feature they have, I put that in quotes, where it can apply updates to your system even if you don't want it to. It has a little pop-up that says, if you would like us to delay applying this update, click, tell us how many hours you want us to delay. But they don't actually allow you to stop it. So continuous delivery done right is a very good thing. But in some cases, it's not such a good thing, as in the case of what Microsoft did with Windows 10. One case where it is happening all around us is on our mobile devices. I have an Android phone, and on any given day, I usually have some message saying, these applications have updated. It didn't ask my permission to do it, although I understand there's probably a setting in there where I can turn that off if I want to. But the default, of course, is to let it happen. In the case of a mobile phone, it's not going to reboot my phone most of the time and cause me to lose work as a result of doing that. So we are surrounded with devices and services that we're using every day that now update multiple times per day and can release updates at any time. So that puts pressure on companies in several ways. It creates just a general pressure to release more quickly, but it also creates a potential for competitive advantage. If a company that can release more quickly and reliably while still maintaining quality, over time will have a competitive advantage over companies that technically they're just not able to keep up. Right, what are some barriers to continuous delivery? Let's say you're in an organization that knows it needs to go faster and wants to go faster. What are some of the things that might stop you from doing that? Well, one thing is that doing continuous delivery really requires multiple skill sets. I think of it as very similar to where testing was about 20 years ago. 20 years ago, there was very little test automation that was happening. There was no such thing as an SDET. That's my job title. That didn't exist roughly 20 years ago. And people had to figure out how to do test automation and how to get that training. There were no courses in it. And continuous delivery is kind of in a similar state right now. Yeah, to do continuous delivery, you need to not only be a developer, you have to know how to do infrastructure automation or be willing to learn it. You have to do some of the kinds of things that a skilled system administrator would do, like creating a script that will update hundreds of machines all at once. System admins do things like that all the time in large organizations, but many developers don't necessarily know how to do that. And so it can be a challenge to either find people who have all those skills or assemble teams to do that. Another barrier that exists in the industry is there are not many end-to-end solutions for doing continuous delivery. There are some starting to emerge in the last year or two, but when I get into the latter part of the talk where I discuss the system we built at our company, when we started that process, there was nothing that could work with what we needed to do. And many of the solutions that are available are very vendor-specific, or they require you to build in the cloud. And while that's feasible for many companies, it's not feasible for everybody. Finally, a barrier that can exist is business context. So your business may be such that it's just not feasible for you to do this. However, even with all these barriers, it is possible to do continuous delivery, even if you have a lot of these obstacles. And that's what we did at my company. So most of the rest of the talk, I'm going to talk about what we did at Vertafore to do continuous delivery. So a little bit about Vertafore. We make software for the insurance industry. Not the most exciting industry, perhaps, but it's actually one that's undergoing a lot of change. We provide basically information solutions for agencies, carriers, and other entities to run their business. And it's a privately held company that's grown over time, so we have a very mixed technology stack, which makes it difficult, kind of challenging to do deployments. But dozens of products, and we're headquartered in Bothell, Washington, which is near Seattle, just north of Bellevue. A little bit about myself. I mentioned that I've been working in test automation for about 20 years. My first degree was in mechanical engineering. I graduated college right when the oil industry and the aerospace industry were both in the tank at the same time. So and it ended up in software. Started as a manual. My first job after I made that change was as a manual tester. So I did that for about a year. Quickly discovered automation. Been doing that for years and haven't looked back. I now work mainly in build, deployment, and infrastructure automation, although I still do some test automation. At my company, I've taught classes internally about on Selenium, using Jenkins, which is one of the tools we use, and Chef. And I already mentioned, well, I live in Renton, so I have to commute through the Bellevue mess on 405 an hour each way every day. If you're familiar with the Seattle area, you know that, what that's like. As far as just some of my interests and hobby, I spend a lot of time playing computer strategy games. Does anybody here play Civilization? Aha. Civ 6 coming out next week. Yeah, very exciting. Yeah, I'm very excited about that. I read a lot of history and historical fiction. This is my favorite set of books and TV series. This is by a British author named Bernard Cornwell, and they made it into a TV series last year. Kind of like this little blurb, kind of like Game of Thrones, but based on real history. This is the 9th book that I just read a month ago, and the 10th book is coming out next month. Does anyone know the name of this character? It's not, I'll give you a hint, it's not Jon Snow. Okay, so that's kind of a dig at the Game of Thrones fan. This is Uhtred of Bebbanburg. He is a Saxon nobleman who was captured by the Vikings as a boy, raised as a Viking, and all the misadventures that he goes through in the course of his life make pretty good reading. So I'm just going to throw that in there. And so you'll notice a little bit of a medieval theme in a couple of my slides, and this is why. By the way, I think this guy is a kind of an interesting metaphor for the kind of for a person who's doing continuous delivery, because he's very resourceful, very impulsive. He's he's smart, and he tells people exactly what he thinks, and sometimes that gets him into a lot of trouble. But he is always manages to get out of the situations he's in. So a little bit of inspiration there. So the project that I worked on started in 2013, and my company assembled a team of people to work on it, and there have been some changes over the personnel in the past 3 years, but it's been about 6 to 8 people the whole time. A couple of SDETs, several QAs, a few system admins, and what we were tasked to do was to implement a continuous delivery system for essentially most of our products, over 20 of them, and they made us a team that was essentially dedicated to this project. We don't do product development day to day. We don't write test cases. What we do is we build all the systems that the people who are doing that use to get their product moving out the door. And the motivation for creating this team was, well, part of it was we were all pretty good at automation. The SDETs in the group were known to be good at that, and so what management said was, okay, nobody in the company knows how to do this. You guys are smart guys. You know how to do automation. Figure this out. Now, we didn't run away. We actually stayed and we actually did it. But the motivation for doing this was that releases were very painful at that time. A release would typically start on a Friday night, and it would go into Saturday morning, maybe into Sunday morning, and if you were lucky, on Monday, the system would be back up. And they were so painful and had such a high failure rate that they did them just 4 times a year. That's how it was. And there were a lot of reasons for that I won't get into, but essentially, the people who our release engineering team were the most unhappy group I've ever come in contact with. They were just, a couple of times a year, essentially, they lost an entire weekend with their families. So, and sleep, and it would take them time to catch up on that. So, not being able to do this was impacting our customers because we couldn't get changes out as quickly, and it was impacting our people who had to do the releases because, it was impacting their weekends. So there were some barriers to this project that we had to deal with. One of them is there are certain government regulations that our company is subject to because we have insurance information, including health information. Has anybody gone to a new doctor's office in the last couple of years? Anybody? Okay, several people have. You probably had to fill out there was a piece of paper they gave you called a HIPAA privacy form, and you had to fill out a form saying that you'd been given that and read that. Well, there is there's sort of a back end to HIPAA, which basically says that you have to very tightly restrict the systems that have this information. You can't just let anybody get into it. And because of that, and other regulations, we have other types of data that have similar regulations to that, but that's just an example, or it's one of the ones that apply to us. We really don't have what is sometimes called a DevOps culture, right? And even though we're moving that direction, there are some ways in which that's not going to happen. There are strict organizational walls between development and operations that are rigorously maintained. I don't have access to production. I did for a while, but there are some reasons why I didn't want to continue to have that. But the bottom line is our developers cannot just push a button and deploy into production anytime they want. Another reason is that we have customer agreements that limit when we can release updates, both in terms of time of the week, time of the month. Certain customers run their reports, monthly reports near the end of the month, and time of year. And that, again, makes it difficult to do the kind of push-button releases to production. In addition, because of all the pain that we've had with releases in the past, there's a very strict process about changes to production. There's actually a review board that has to review everything before it can go out. On top of that, our security team has a rule that basically says we cannot put any product source code in the cloud. We do actually work with a cloud provider for a lot of our test environment, and we can put test code up there. We can put built artifacts, but not the actual source code itself. So we can't do our builds in the cloud as many people are able to do. But again, even facing all this, we did not quit. We did not run away. We persisted. And so what I'm going to describe in the next couple of slides is what we built and how we built it. We started with our continuous integration system. For that, we used Jenkins. And thank you. We have several different types of jobs that run on Jenkins. We have build jobs that will create an artifact, deploy jobs, which will deploy the artifact into the test environment or whichever environment it's going into, test jobs that run our tests. Unit tests run as part of the build job typically, but we have integration tests that test web services. We also have Selenium tests that test the user interface, and those will run in the test jobs. And finally, we have promotion jobs, and what those do is if all of the automated tests for a build have passed, then we do what's called promotion for that. The other piece of what we built, major piece, is Artifactory. Artifactory is a binary artifact repository. You can think of it as a large database for everything that you built. And we have a number of different repositories within Artifactory. You can think of those as folders in a way. All of the built artifacts initially go into what we call development repo. And if it's been promoted, in other words, if it's been tested and we've verified that it's working correctly, it goes into the release repo, which means it can be released. So only promoted artifacts can ever be released in our process. So another tool that we brought in for this process is Chef. Chef is an infrastructure automation tool. It's used it's used to basically define how machines are built. And we use it actually to define the configuration of our Jenkins and Artifactory servers. So Chef installed all the software on those machines. And whenever we want to make an update to our Jenkins and Artifactory servers, we make an update to the Chef scripts to do that. And what it's done for us is it's helped us to standardize all of our machines so that we don't have a bunch of different hand-built machines that may work differently. So if you have a job that can run on a particular type of build machine, every other build machine we have of that type is exactly the same, and we have 100% confidence that that job will work on every machine of that type. So that's what Chef does for us. But there was a missing piece. As we put all this together, we realized there was something else we needed. And what we came up with is something we call an automated test gate. And basically what that is, it's a simple criteria that has to be met for an artifact to be promoted. Here are a couple of examples. A test gate has a gate type, a pass score percentage, and a results type, which really means what type of test was this? Is it a JUnit test? Is it a Microsoft test? Is it an NUnit test? That's what that is. And in this first example, really what that says is you can promote your artifact will be promoted if 100% of your unit tests pass. And the second example is a UI test gate that says your artifact will be promoted if 95% of your Selenium tests passed. And this turned out to be really helpful. Why do I think these are awesome? They run very quickly because a test basically what they do is they're a Jenkins job that looks at the test results file from another Jenkins job and said, did you meet the criteria you set? Yes or no? Very simple. Runs in seconds. And these are running constantly throughout the day. And now, even though I do a lot of the support for our Jenkins build server, I don't write that many of the jobs myself. The development teams do that. And they can decide which test gates to use and what the criteria are. So, and you can chain these together, I should mention that. So you can have a series of gates, all of which have to be passed through in order to successfully promote your build. What we found in practice is once we implemented this and said here, you can use this test gate technology, the teams would just set their pass score to 100% for pretty much all their gates. For some of the UI tests, UI tests can be a little flaky. There was a talk on that, I think, yesterday. I don't know if you went to that. But pretty much the teams did that themselves. We didn't force them to do that. By the way, we didn't force any of the development teams to uptake our system, but within 6 months, virtually all of them did, because we made it easy for them to use. One thing we did was our system supports manual gates, so if they want to have a person do the final approval, even if all their automated tests pass, they're just not comfortable with letting a machine make that decision, they can put an extra stop in there to where a person can make that decision. Okay, so that worked great for our development environment. But we encountered a barrier that required some creative thinking to get to production. By the way, does anyone know which castle this is? This is Stirling Castle in Scotland. I've never been there, but I really want to go there because look at that gate. Isn't that awesome? Can you imagine having to try to attack that place? When we started to have conversations with our security team and our operations team, please, can you let Jenkins deploy to production? It kind of felt like that, being down there, and they're up there with the archers, and yeah, it was kind of a tough conversation. So we couldn't deploy directly to production. To give you a little background, we have a staging environment and a production environment. Both of them are network isolated. And web requests from the outside, except to the actual endpoints where the customers are using our product, are restricted. We couldn't simply open a hole and say, let Jenkins deploy directly into there, because if they did that, anybody could get access to that hole, that port. So we found a way to deploy indirectly. We put Artifactory servers inside of staging and production. And these servers talk back to our main Artifactory server every 10 minutes, and they say to our Artifactory server, do you have any new artifacts for me? Anything new? Every 10 minutes. And they're doing this continuously. And it can only see the promoted artifacts in our release repository. So anything that has not been promoted, that's still in test, aren't even visible to these machines. There's no physical way for them to make it into production. We also put Jenkins servers inside of staging and production, and our release engineers run the same Jenkins jobs in the same way. They just basically they have instructions that say run this job name and put in this build number, and they have to trigger it manually, so it can only be done during our release windows and only by the people who do have access to these environments. So I'm going to spend a few minutes on this slide because it's really important to understand how the system works. So on the left is our development environment. And in our development environment, we have a Jenkins build server, which starts a job on a build agent. That build agent creates an artifact, sends it up to Artifactory. A deploy agent pulls it out of Artifactory and deploys it to a target server. And kind of at the bottom there and in the background, you have a chef server that's configuring all those machines and making sure that everything is the way it's supposed to be. And similarly, in staging and production, I've only shown one of them here, but you can imagine a third one off to the right if you wish. They're exactly the same. We have a Jenkins deploy server and deploy agent, which pulls an artifact from the Artifactory cache. The Artifactory cache server at the top there on the right is the one that's polling every 10 minutes and saying to our Artifactory server in development, do you have anything for me? Do you have anything new? Any new released artifacts? And because that's coming from inside the environment, our security people approved that, and we were able to do it. We cannot push, you see the red arrow with the red X, we cannot push directly into either of staging or production. So what happens then is that exactly the same as what happens in development. Our products get deployed onto the target servers, done, and we have a chef server that makes sure all of those machines are configured correctly, continuously. And the reason we brought in Chef into the mix is because we initially built these machines by hand. And we found that because they were built by different people at different times, there were subtle differences between the Jenkins over here and the Jenkins over there. And that would cause deployment failures. But once we brought Chef into the mix to control that, those went away. So what are the results? We now have over 200 people using our Jenkins server for their builds and deployments. We have 800 Jenkins jobs on that machine. It's currently building over 8,000 artifacts a month. Only a small fraction of those actually get promoted into production, but it's building constantly. We now release on a monthly basis. We've been doing that for over 2 years. We have an average of 10 products that go out with each monthly release, and they've been 100% successful. Successful in the sense that there haven't been major deployment issues. There are bugs. There are going to be bugs, but that's not my job to prevent all of those. My job is to make sure that they can get out there without the deployment system causing a delay or causing a failure. And so deployment failures on the release nights have declined enormously. They're usually done by midnight on Friday night instead of, Saturday morning, Sunday morning maybe. People have their weekends back. They can spend time with their families. And our customers can get their releases faster. And if we do need to do something quickly, say there's a problem on release night and something has to be fixed right now, we can do that and get it all the way to production in under 30 minutes. So, some patterns we kind of learned through this process. And I'm almost done, so I know I'm running a little past the 30 minutes. And if you're in a situation where you're able to use a commercial off-the-shelf continuous delivery system, that system will do all this stuff. This is really more if you're kind of in the situation we're in where we have to build our own from scratch. So one pattern I would strongly recommend is to separate your build and deployment code. Let's say that your operations people tell you that, okay, your application needs more servers. And so you have to add more target servers to your deployment script. If you have to make a build of your entire product for that change, you're doing it wrong. You should separate out your deployment code so that your product build, if you need to make a change to your deployment in any way, it won't affect, you don't have to do another build of your product to do that. And actually this was a problem early on. There were a lot of cases where we weren't doing this and we had to fix that. Whether you're using an automated system like Chef or not to configure your machines, please standardize your machine types. If you have 20 different build machines and they're all built differently because they were built by hand by different people at different times, you're going to have a mess to maintain. Separation and promotion of artifacts, that's very important. You need to be able to identify what can be released and what cannot, and have some system for doing that. And if you can automate those decisions, that is very, very helpful, because that will speed up the process. However, even if you have to somehow have a manual gate in there, some manual check that says, okay, even if it's past everything, I still want a person to make the final decision. That's okay, but automate as much as you can in that area. These are some a little bit more maintenance type ones that maybe are a little subtle. Some questions you'll have to think about is, how long do I keep my build artifacts? Let's suppose an artifact was never released. Do I keep that forever? Do I delete it after a certain amount of time? And how long do I keep artifacts that were promoted but never actually released to production, or artifacts that were actually released? There's no right or wrong answer to these questions, but unless you have an unlimited storage budget, you'll have to think about it at some point. We keep development artifacts for 3 months, so the development team has 3 months to get their artifact promoted, or we just delete it. And every once in a while, somebody will forget about that, and I have to explain to them, oh yeah, it's not there anymore in Artifactory because you didn't promote it after 3 months. Oh, okay. They'll redo the build. They'll find a way to get back to where they need to be. If you are building a custom system like this, you have to train your users continuously, because it's going to evolve. You're going to change it, and you're going to have new users coming into your company who don't understand how this works, because it's a customized system. So we've had to do a lot of internal training, and you have to be patient with people and explain to them how to be successful in getting there through this system. The other thing we found is that there are some things that we don't want our users to do that no matter how hard we try, we can't prevent them from doing it in the system. So we have to do a kind of whack-a-mole, where we have Jenkins jobs that look at the other Jenkins jobs to see if users are doing certain things that we don't want them to do. For example, there's nothing in our system to prevent somebody from creating a Jenkins job that releases directly to the release repository without being tested. We can't prevent that, but we can check for it after the fact and say, stop that. So we do that. And there are other examples. And the paper gets into some more detail on each of those patterns. So final thoughts. Delivering software to customers, it's not an optional feature. You have to do it. You might as well do it well. I could argue it's even your most important feature. Don't let barriers like the ones I talked about stop you from automating, transforming your delivery pipeline. You may only be able to do part of it today, but the knowledge you will gain through that process will help you to understand better how to do delivery in the future, and better tools will be available in the future. If you do this, be prepared to learn and to reinvent constantly, because the technology is rapidly evolving and changing. Quick acknowledgement. I didn't do all this. There was a whole team of people that did this. Some of these have moved on to other companies. I just wanted to acknowledge all my colleagues who contributed to this work. It was a big project that involved a lot of people, all these folks to some degree or another. And here's my contact information, and with that, I will take any questions. Thank you. Sure. Yes, that's kind of an important piece of it, isn't it? Absolutely. There we go. Yes. And this gentleman raised his hand. Yeah. Or did you? Yeah. Yeah. Did you have one before that, or?
I did.
Yeah.
How are you getting the Jenkins scripts themselves from the development into the staging?
Oh, excellent question. Actually, we use Chef to do that. We have Chef, it's part of the Chef recipe that defines our Jenkins servers. We do have to manually update, we do have to manually update the recipes to get them from the Chef server on the left to the one on the right, or the ones on the right. So there are some manual steps in the process. But we only have to do it, we do it during a window of time before each monthly release. So other than that, we stay out of those environments. Yes. You had a question, sir?
Yeah, I would like to with this is probably the same as you get for high level management. That if something terribly goes wrong once you deploy something. So my question to you is, do you have a solution for aborting or undoing or going backwards with prior release? Maybe you don't need that. Would you feel, first of all, do you have that? And then would it make you be able to sleep better at night?
Right. So the question is, do we? I'll rephrase it. The question is, do we have a rollback process? Right. If something goes wrong, do we have a way of rolling back? And the short answer is no. We roll forward, which means that we would redeploy the earlier version, which is still going to be in our system. The artifacts will still be there. The build information will still be there. But it's not a rollback as such. It's a redeploying of what was there before. So that's kind of the survival strategy for that. And that's if we can't do a quick fix. Oftentimes they will encounter an issue where it's going to require a more bigger change than what they can do during that release window, and they will do a roll forward to the previous version. But it's not a rollback as such. I mean, a rollback can involve like undoing a database, that sort of a thing, a database rollback script. And we have some of those things, but in general, no. We do a roll forward to the redeploy the old version. Yeah. Other questions? I hope this isn't too scary, because it's complicated. Yes, in the back.
So Jenkins is doing automatic versioning on that, or where does that get from?
Oh, the versioning. So the versioning typically there's a build version, so it's a build number. So that is happening automatically. It auto increments that. But in terms of like the version of the product, or like if someone was looking at an about window and what the version number would be there, that's happening upstream of Jenkins. We have several different source management systems we use. A lot of our products are .NET, so they will use Team Foundation Server, and there's like a pre-build that happens there. With gated check-ins and other processes that are upstream of us, and that's where that version number would be set typically. Yeah. Yeah. Other questions, observations? And if again, there are more details in the paper. If anybody wants to, reach out to me either in the rest of the conference or afterwards with questions. I'd be happy to help. How the heck, what are the things we shouldn't do, or how do we do this? I'd be happy to help to answer any questions and try to steer anybody in the right direction. Because this is not easy. This is hard stuff. It took us about a year to figure it all out and to build it. It's been running with only minor maintenance for 2 years ever since. So. Thank you.